What if the most advanced bunker in the world was not defeated by a larger explosion, but by a weapon designed around one simple idea? The mountain itself is no longer protection. For decades, Iran built its military strategy around a single assumption. Some targets could disappear underground. Some weapons could be hidden beyond the reach of conventional air power. Some facilities could survive because the earth above them was stronger than any bomb below the sky. But now, thousands of feet above the Iranian landscape, a different calculation is taking shape. Because the question is no longer whether a bunker can survive a direct hit. The question is, how deep can an enemy dig before technology learns how to follow? The image begins with a mountain, not a city, not a battlefield, a mountain. On satellite imagery, the terrain south of Isfahan appears almost ordinary, a rugged landscape, dry valleys, roads cutting through empty terrain. But hidden beneath that rock is something different. A second battlefield, a world of tunnels, reinforced chambers, missile storage areas, command facilities, and production networks designed for one purpose: to survive. And then the mountain changes, a flash, a violent eruption from inside the earth, not a surface explosion, not a fireball spreading outward, a pressure wave escaping from somewhere below. Because this is not simply a bomb hitting a target, this is a weapon attempting to enter a place the enemy believed weapons could not reach. The weapon at the center of this story is the GBU Faye Advanced 5,000-pound penetrator. But the bomb itself is not the real hero of this story. The real hero is the idea behind it, penetrating the invisible battlefield beneath the surface. Because modern warfare is no longer only fought across oceans, deserts, and skies. It is fought through layers, sensors, data, concrete, rock, supply chains, and decisions made thousands of miles away. The mountain is only the visible part of the conflict. The deeper battle is about whether protection can survive when technology changes the rules. But here is the problem. A stronger weapon does not automatically create victory, because every time one side builds a new capability, the other side changes the battlefield. The bomb evolves, the bunker evolves, the intelligence network evolves, and the competition continues. This is the oldest cycle in military history. The shield becomes stronger, the sword becomes sharper, and the real question becomes, which side adapts faster? For Iran, underground warfare has never been just about hiding equipment. It has been about preserving strategic options. For more than 4 decades, Tehran has understood a simple reality. It cannot compete with the United States in traditional air power. It does not have the same number of advanced aircraft. It does not possess the same global network of bases. It does not operate the same scale of intelligence and surveillance systems. So instead, Iran built a different kind of deterrent: missiles, drones, coastal defenses, underground facilities, a network designed to survive an initial attack and still have the ability to respond. The mountain became part of the weapons system. Because the bunker was not only storing missiles, it was storing uncertainty. A commander looking at an underground facility has a problem. How many weapons are inside? How deep does it go? How many entrances exist? How quickly can the enemy rebuild? How much remains after the strike? The uncertainty itself becomes strategic power. And that is the part many people miss. A bunker is not valuable because it cannot be destroyed. A bunker is valuable because an opponent cannot be certain what remains after trying. But now that calculation is being challenged, because the United States is not approaching these targets the way earlier generations approached hardened facilities. It is not simply dropping explosives and hoping for damage. It is combining intelligence, precision weapons, electronic warfare, aircraft, and global logistics into one system. The bomb is only one piece. The real weapon is the network behind the bomb. Inside an American command center, analysts study satellite imagery, engineers examine tunnel entrances, signals specialists search for electronic activity, Pilots prepare routes, weapons officers calculate release points, thousands of individual decisions come together before a single weapon ever leaves an aircraft. The explosion is the final moment. The war begins much earlier, and that changes everything, because the mountain is not fighting the aircraft. The mountain is fighting the entire system. But here is the contradiction. The deeper Iran builds, the more expensive the problem becomes for the attack. Underground warfare creates a difficult equation. A normal target can often be destroyed once. A buried network may require repeated strikes, constant intelligence, and continuous pressure. The attacker must spend resources proving something is gone. The defender only needs to preserve enough capability to remain dangerous. That means the battlefield is not simply about destruction. It is about cost. Who spends more? Who adapts faster? Who can maintain pressure longer? This is why the GBU-FE matters. Not because it is the largest weapon in America's arsenal. It is not the massive GBU-FE, massive ordnance penetrator carried by the B-FE bomber, remains in a different category entirely. That weapon exists for the hardest underground targets. The targets built around the assumption that almost nothing can reach them. But the GBU-FE fills a different role, and sometimes the middle layer is the most important one. A military does not need the biggest weapon for every problem. It needs the right weapon at the right moment. The GBU-FE represents that Shift A5000 pound penetrator designed to strike hardened facilities without requiring the most limited strategic platforms every time. It gives commanders another option, and options are what modern warfare is really about. Because a military with more options can force an opponent into more difficult decisions. A missile site hidden underground creates one question: can we reach it? A penetrator weapon changes that question. How much of the network can we force the enemy to move? That is a completely different battlefield. The weapon itself is built around surviving the first moment of impact. A penetrator wants to wait. It must survive the violence of impact. Rock, concrete, earth, pressure. Only after reaching the intended depth does the weapon release its explosive force. The goal is not a bigger explosion. The goal is an explosion in the correct place. That distinction reveals something important about modern military technology. Precision is no longer only about hitting a location. It is about controlling the conditions of the strike, the timing, the depth, the sequence, the effect. A weapon is becoming less like a projectile and more like a decision delivered at extreme speed. But the question remains: why did Iran build these underground systems in the first place? Because history taught Tehran that exposed military power is vulnerable. During the Iran-Iraq War, cities and military facilities faced missile attacks. The lesson Iran absorbed was clear: survival requires redundancy. Hide the assets, spread the network, make the enemy uncertain. That philosophy continued for decades. The result was not one bunker. It was an underground architecture, missile storage, assembly facilities, launch preparation areas, command locations, a hidden military infrastructure beneath the surface, from above. The landscape looks empty below. It becomes a battlefield. And this is where the first major contradiction appears. Iran built these facilities because it understood American air power. But American air power has spent decades evolving specifically to defeat systems like this. The defender built deeper shelters. The attacker built deeper penetration. The defender created more entrances. The attacker improved intelligence. The defender hid underground. The attacker moved the battlefield underground. The mountain was supposed to remove vulnerability. Instead, it changed where vulnerability existed. And that is the strategic mystery at the center of this conflict. Everyone sees the explosion. Everyone sees the bomb. Everyone sees the destroyed facility. But the part most people miss is this: the real battle is not happening at the moment of impact. It is happening in the competition before impact between concealment and detection. between endurance and precision, between a country trying to preserve its options and another trying to remove them. Because the next phase of this conflict will not be decided only by who has the bigger bomb. It will be decided by something far harder to measure: who can control uncertainty. And that leads to the deeper question. If underground weapons were designed to survive the first strike, what happens when the first strike is no longer the beginning of the battle? What happens when the battlefield continues beneath the surface? Everyone thinks this battle is about bombs destroying bunkers. But the real battle is about something much harder to destroy: a nation's ability to make decisions under pressure. Because the purpose of an underground missile network was never simply to protect weapons. It was to preserve choices. A missile hidden beneath a mountain represents more than explosive power. It represents the possibility of retaliation, the possibility of negotiation, the possibility of creating uncertainty in an opponent's mind. And when a weapon system attacks that network, it is not only attacking concrete and steel, it is attacking the decision, making structure built around them. That is the transformation at the center of this conflict. The surface war is about aircraft bombs and explosions. The hidden war is about strategic freedom. Who still has options after the first strike? Who can force the other side to react? Who controls the next decision? The lesson here is simple. Modern warfare is increasingly becoming a competition to control the enemy's future choices. And that is why underground facilities matter so much. Because the most valuable thing inside the mountain may not be the missile. It may be the time the missile buys, the hours, the days, the uncertainty, the ability to make an opponent hesitate. But now that advantage is being challenged, because the United States is not fighting the bunker alone. It is fighting the entire system that keeps the bunker relevant. A satellite passes overhead. An intelligence analyst studies a new image. A signal appears. A pattern changes. A suspected facility becomes a confirmed target. Then the information moves from sensors to commanders to aircraft. The bomb is only the final link in a much larger chain. And this changes everything, because a bunker can survive a weapon. But can it survive a network? That is the question Iran's military planners have to consider. For decades, underground warfare depended on one assumption: if you cannot stop the enemy from finding you, you can at least make destroying you too difficult. But modern warfare is attacking that assumption from multiple directions. Better satellites reduce concealment. Electronic intelligence reduces surprise. Precision weapons reduce distance. Artificial intelligence accelerates analysis. The battlefield is becoming less about finding a target. It is becoming about finding it before the enemy can move. And that creates a new contradiction. The more expensive and sophisticated a military facility becomes, the more valuable it becomes as a target. A simple weapons storage site is dangerous. A highly protected underground command complex is dangerous and symbolic. It tells an opponent, this is where our survival is organized, which means striking it creates psychological effects beyond the physical damage. A bunker is not just a building. It is a message. Destroying it sends another message. And messages matter because wars are not fought only between militaries. They are fought between perceptions. Inside Tehran, leaders must now consider questions that did not exist decades ago. Are underground facilities still reliable? Can missile stockpiles remain protected? Can retaliation still be guaranteed? Can deterrence survive when the opponent can reach deeper than expected? The bigger picture is that military power is not only measured by what a country can destroy, it is measured by what it can make another country fear losing. And this is where technology meets geopolitics, because the consequences extend far beyond one mountain in Iran. Look south, toward the Strait of Hormuz, a narrow waterway connecting the Persian Gulf to global energy markets. On a satellite image, it appears like a thin blue passage between landmasses. But economically, it is one of the most important points on Earth. Every day, energy supplies move through this corridor: oil, gas trade, global prices, industrial production. A conflict here does not remain local. A missile facility inside Iran is connected to markets thousands of miles away. A bunker strike in Isfahan can influence decisions in Washington, Beijing, London, and Tokyo. That is because military systems and economic systems are now connected. A missile stockpile creates military leverage. Military leverage creates political influence. Political influence affects energy markets. Energy markets affect the global economy. One underground facility can therefore become part of a worldwide strategic equation. But here is the problem. Destroying weapons does not automatically eliminate the reasons those weapons exist. A country can lose missiles and still seek influence. It can rebuild facilities, adapt tactics, change technology, move resources. The physical battlefield can change faster than the political battlefield. And that is why wars are rarely decided by one successful strike. A bomb can destroy a structure. It cannot automatically change a strategy. The question becomes, can pressure create a different calculation? Or does pressure simply force an opponent to adapt? This is the invisible battlefield. Not the mountain, not the missile, the calculation, the decision. The moment when a leader asks, is continuing this strategy still worth the cost? That is where modern warfare is moving. The most powerful weapon may not be the one that causes the largest explosion. It may be the one that changes what the enemy believes is possible. And that is why the GBU-FE represents something larger than a single bomb. It represents a shift in military philosophy. The goal is no longer simply destroying enemy equipment. The goal is reducing the enemy's strategic options. Every radar destroyed reduces awareness. Every command facility damaged reduces coordination. Every missile storage site threatened reduces confidence piece by piece. The battlefield becomes smaller, not because territory disappears, because choices disappear. But there is another side to this equation, because every advantage creates a new vulnerability. The United States may have advanced aircraft, precision weapons, and intelligence networks, but these systems require enormous investment. They require logistics, maintenance, supply chains, global positioning, fuel, human expertise. A sophisticated military machine is powerful because of the system behind it. But that system itself becomes something an opponent may attempt to challenge. The future battlefield will not simply ask, who has the best weapon? It will ask, who can sustain the system that makes the weapon effective? This is why future conflicts will increasingly involve factories, data centers, satellites, energy infrastructure, and industrial capacity. The battlefield is expanding. The weapon may launch from one location, but the war supporting that weapon may stretch across the entire planet. The lesson here is that modern warfare has become a contest between visible destruction and invisible endurance. A missile exploding is visible. A supply chain decision is not. A destroyed bunker is visible. A political calculation is not. A fighter aircraft crossing the sky is visible. The intelligence network guiding it is not. And often the invisible systems decide the outcome. So where does this leave the mountain? The mountain was built as a symbol of protection, a place where weapons could survive, a place where uncertainty could be preserved. But now it represents something else. A question. Can physical defenses survive in an age where information moves faster than weapons? Because the future of warfare may not belong to the side that builds the deepest bunker. It may belong to the side that understands the battlefield faster. The side that sees first, decides first, adapts first. The side that can turn information into action before the opponent understands what is happening. That is the new strategic competition. And it extends far beyond Iran. Because nations around the world are watching this conflict for lessons. China is studying how precision weapons challenge hardened facilities. Russia is studying how air defenses survive under pressure. Smaller states are studying whether underground networks can still provide deterrence. Everyone is asking the same question. In a world of satellites, artificial intelligence, and precision strike systems, can anything truly remain hidden? The question is no longer whether a mountain can stop a bomb. The real question is whether any military can protect its most valuable assets when the battlefield itself is becoming transparent. Because the next generation of wars may not be won by the weapon that hits hardest. They may be won by the system that understands the battlefield first. So the final question is this: do you believe future wars will be decided by bigger weapons, or by the ability to decide and adapt faster than the enemy?